All right, hey there, fellow coder. If you are looking forward to a second part in our series where we are building our application and deploying it using Docker and containerizing everything, then this is going to be great for you. You're going to really like this video. We're going to be talking about the back end of the application now and building it as a Docker container, image, then container, and then we will hopefully figure out how to put together the front end and the back end containers. We'll see if we have time for that in this video. So if that sounds like it is of interest to you, stick around. All right, fellow coder, let's get into this mess of text that you see in front of you. So just like we spoke about in the previous lesson, I was talking about the Dockerfile that we built out for the front end. It was a very my goodness, very simple Dockerfile, not too much going on, only 5 steps here. So we're going to be taking the same knowledge that we've learned of Docker and port it over to the back end of our application. So in the back end here, let me just close all my filter out of my closed projects. We see this is the back end. You can't tell that this is the back end folder that is the root folder, but it is. Maybe if I can right click and say properties, does it show? Yeah. So this shows assignment submission app / back end is the path that we're looking at the root. So within the root of that, we have the Docker file. Okay, so that's what I've added in here, and that's what we are looking at currently. I can close all other tabs so that we can focus on just this one. Now, this build file, or this Docker file, is a little bit more involved, but don't worry, I will go through each of the lines to explain what's going on. So step 1 here, we start with the same from. So just like we did in our previous lesson with our node image, we had a node image that was node 17 image that was built off of the Alpine version of Linux, and that's where we started from. That was the image that's already been pre-built and that's hosted in hub docker.com or whatever. So it's the same idea here. We're starting from an image that also is already hosted on the Docker Hub, publicly and freely available for us to use. This one, we're using an open JDK version. So this is an image that will be that will contain our JDK installed on it. Because how do we run Java? We need to have an SDK. We need to have an environment to run our Java code on, and that is typically one where we have Java installed. So in this case, this is Java 11 that is being installed, and that is the image that we're pulling from. Now, there's probably many images. Again, this one just worked for my case. There might be a better one, but this is the one that I found that works. So we pull from that. And we start from that as our base image, and we're going to give it an alias. We're going to call this build, and that will be important for our second step that we'll get to. All right, so the next step that we see here is this work directory step, which says it sets the current working directory inside the image. Now, that's a little bit not descriptive enough. So what this will do is this will create a folder on this image that we are pulling from Docker Hub and starting from as our base image. It will create the app folder if it does not already exist. And it won't, because this is just a base image. So yes, it will create this folder inside of the image. And this is where we can deploy our app to. Note, we should be doing this over here in our front end as well. Like I said, the layout of the folder structures and everything wasn't great in our front end, so we're going to come back to the front end build and add this working directory to it. I just didn't want to throw that into the previous video. Don't want to overwhelm you too much. Now, it will create the working directory, this app directory, and what this means is it will set that as now the new base working directory. So it's almost like this, in my opinion, is equivalent to doing a make directory for app, right, on the root, and then once it's made, cd into it. So we're changing the directory, changing our position into it. So it's kind of like this work dir command is kind of like combining these two commands. Make it and change directory into it, so that's now your root working folder. Cool. So now what we're going to do is we're going to leverage the copy command. And again, if you flip back to the front end, all the copy command does is saying, hey, grab the files from the host machine, which is our machine, the machine right now that I'm recording this video on and talking to you, that is the host machine. It is the local host, so to speak. In the future, this is going to be another server, but we'll get there later. So that's what we're doing here. We're copying from our machine, which is literally grabbing files here, which is going to grab this file right here, mvnw. Grab that and copy it over to the now working directory of app, right? Because remember, we've changed directory into this app directory. So it's going to copy mvnw into /app, and it's going to copy mvn or .mvn into the same place with the same file name. We'll have to double check how that works. So anyway, so copy those two files, and then copy the POM XML file. So copy that from our machine over to the app folder. Cool. So far it's just a bunch of copying stuff over. Then we do this. So we run this command called dependency go offline. Now I had to do some research on what this does, but basically it does what this says it does, right? So it's going to build all dependency in preparation to go offline, which means it's going to essentially say, assume that we don't have or won't have internet access, I guess, in the future. Just get everything, copy everything, make sure that everything is on this machine, so there's no tomfoolery going on. So get everything into there, and have it all the dependencies available from Maven. And it says this is separate so that the dependencies will be cached. So I'm assuming that this is a performance thing, and why they're doing that. What happens is when you put this POM command, copy the POM file over before this command, if the POM file changes, then it's going to, if this step changes, so step 1, 2, 3, 4, 5, if step 5 changes, so if the POM file changes, all the subsequent steps change or will not be cached and will be rerun, essentially. So if the POM changes, you have to change everything. So that's why they separated it into a separate line. That way, if the POM does not change, it does not have to rebuild all the dependencies, which takes a long time. Cool. Now, once we have that, we're copying over everything from the source folder. So everything in here, which is our source main, Java. So all the files of our app, all the source code that we've typed in Java will be copied over. Cool. So now we have copied everything over. All of our source code is there. We have all the dependencies preloaded. All the libraries and everything have been downloaded and ready to rock. So now what we can do is we can package it up. So we can package it up such that it can be actually run as using the Java command. So we'll package it up. Now this is skipping the tests. I don't know if you should skip the tests. That's a personal preference. And I'm saying it is skipping the test because I copy pasted this code. I didn't write all this myself, but I can explain the words as to what they're what's going on behind the scenes, so to speak. So we're gonna run and package everything together, and we're skipping all of our unit tests and integration tests. Again, if you want to do that here, essentially if you always want it to package successfully, even if a test is failing, that's what will happen. So even if a test fails here, it's not going to run the test, and it's going to package everything up. So I would recommend that you have another step somewhere in the pipeline that makes sure that you are running the tests at some point. Cool. So then what happens is once you've packaged it up, we're going to get ready to make the directory where all this stuff is going to be moved into, right? So in the world of Java, it creates a target directory. So we'll create a target directory and put our dependency, and I guess, make the dependency directory as well. And if that is successful, then we'll CD into it. So we'll change directory into the target/dependency directory, and then we're gonna run this command. So I'm actually not sure. I don't usually do all this manual command line stuff. I usually let other front end stuff not front end stuff, but IDE stuff do this for me. I'm actually not sure what this does. It looks like it's creating jar files or something. So I apologize. I should have known that ahead of time, but it is what it is. So then what we do is that was sort of our build stage. So we had assigned an alias to this as build. So we're getting all the files ready to run essentially on this image, on my OpenJDK image. So that's step 1. And as you can see, step 2 here, we have another from. So from this same image, we want to do more stuff. So we're going to create a variable called dependency, which just looks at the app folder /target/dependency. And what we're doing is we're copying the files from the build stage. Again, this build here has to match this build here. This is an alias or a variable that we're declaring, saying this is from step 1. So we're saying, hey, from step 1, copy all the files from step 1. So instead of, if we normally just use copy on its own without this from flag, this would assume we're copying from our local machine, right? Our machine that we're, again, I'm recording on and all the files are here. That's our local machine. But when we say, hey, do it from build, it's now saying it's overriding the default functionality of where we're normally copying from, which is the host machine. And we're saying copy it from the image from step 1 or stage 1. Okay, so we're saying, hey, from stage 1, copy all the files in the app target dependency that we just created. Okay, so we just created that directory and copy the files from that dependency / boot whatever into our app library and into our app meta and into our just root app. So classes go into root app. So this is just we're setting it up such that it could be run, and then we are running it here using the Java command. Okay, so Java with some flags and whatnot, and we're pointing it to the main the class file that has the main method. Right, the main function, public static void main string args. So, and we're pointing it to where all the libraries exist as well. So this way it says, hey, I know where the main method is. I know where all of the library files exist, all the dependencies. So I should be able to run Java. So then, what is this entry point thing, and what's with all this setup and everything? This is a bit more advanced. The short form of this, again, this is a whole course on its own, this Docker stuff, and I'm trying to be somewhat succinct and brief with my explanations. So further research will be necessary for you here. But when you say entry point, you're kind of saying start this container up now via this command and let it sit there and run. And because we're calling it entry point, this is sort of the recommended and final step that will happen for this container to be brought up and run. So we're saying this is kind of it. We don't recommend starting this container up in any other fashion. This is how we recommend doing it. Okay. There's another syntax you can use called command, where we could literally copy paste this and it can do the exact same thing. But the CMD command, it's a bit more, you can override this functionality. So this might be a better way to think of this is, again, these two are kind of equivalent, but what this is saying is this is a little bit more optional. You can override this as a starting command for your container versus this entry point here command is a bit more set in stone. It's like, this is, unless you know what you're doing, don't mess with this command, right? So that's basically what our image is doing. The image is getting all of the source code and building all the dependencies and getting it all ready in step 1. And then it's putting all that code into, and all that, I shouldn't say code, all of the files and everything into the appropriate folders so that we can run it with this Java command. Okay? So that's what's happening in the image. So now how do we build this image, right? With Docker, you need to build it and then you run it. That's sort of the 2 steps that are necessary. Now, I've already sort of done this before we started this, lesson. How do you do, is it CLS or clear? There you go, clear. So how do you build this image? Well, Docker build, right, is how you build. Preferably, you should give it a tag to give it a memorable name. We'll call it backend as our tag. And then there's other options that you can we can run this in interactive mode or whatever, but really, you just want to then point it to where the Docker file is. And remember, we just created this Docker file here in the world of Eclipse in the backend folder. So we're just pointing it. We're already looking at the backend folder, so we just do dot to build it. So when I run this, hopefully all goes well. That went so fast I couldn't even get a drink into my mouth. Now, this is abnormal how fast that went because it's been cached. All this has been cached already. So I just, for the sake of brevity for this video, I built it already beforehand, and it probably took, a couple minutes to build everything. So yeah, it won't be abnormal for it to take a few minutes for it to build the image. But now, if we say Docker images, we will have back-end image. We have a back-end and a front-end image. Front-end I recorded yesterday, so it's 19 hours ago. Back-end was just now, before I recorded this video, which was 16 minutes ago. So just to show you, they're there and they're ready to rock. So now we can do our Docker run, right? Now the Docker run caused me issues yesterday, and I've already forgotten what the commands were that I need to be using to run this properly, so forgive me. But Docker run in interactive mode. Specify the port for this one in terms of exposing ports. I promised I would talk about ports and how they work, but maybe that'll be in the next lesson when we sort of bring this all together, because I don't think we'll be able to get this into this lesson. But it's all about exposing ports on from the outside going into the container, and then within the container itself. So it's about from the external and the internal. That's what those two ports are for. One is for the external side and the other is for the internal side. So we're exposing port 8080 externally, and then that's going to be routed to port 8080 internally in the container itself. Again, that's not a great explanation. I will explain that more and show you the ramifications of changing these numbers in a later video. So Docker run, IT runs in interactive mode. We specify the ports. We need to tell it the image, I think, which is back end is the image. And then, since we're running in interactive mode, we need to tell it what the name of the app is that we want to be using as our shell. I forget if it's just sh, right? And then I think we need to tell it, there's another command that we need to give it, which is, this win pty command. And then I think I can say exclamation point twice, and it'll run it'll append the command that we just did previously. Boom. So now, sweet. So now you see, okay, connection refused. All right. Now, that's interesting. It didn't stay inside of the container that we were firing up. Maybe because it failed to run. Let me see. So the error is it couldn't connect to the database, right? So, which makes sense because the database is on port 3306, which inside this container there is no MySQL port or MySQL server running inside of this container right now. So I tried to connect to the MySQL server on localhost because that's what we're telling it to do in source main resources. Right? Source main resources, we're saying, hey, go look at localhost 3306 and find this particular, database. But inside of this container, there is no MySQL running, right? It's not in that container, so it can't connect to it. So really what we need to do here to fix this problem is to point it to a database that's, outside, it's not a localhost, in other words. We have to give it a more explicit path or URL to a running database. And I hadn't practiced this and thought about how I could achieve that. So give me a moment while I think about how to solve that problem. Okay, so I paused the video and thought about this for a moment. And I think what I'm going to do is I'm going to call an audible here on my on the path I was planning on. And I'm going to have another video where I'm going to set up yet another image that will have another container specifically for a MySQL instance, right? So we can have another container that runs MySQL, and it's called composing. When we put all these containers together, they'll be on the same network, and they'll be able to talk to each other on that same network when they're all composed together. That way, we don't have to have like an external database, and instead of saying localhost, we can specify the name of the network, so we can call it like the assignment, submission app will be the name of the network or something. So assignment submission app :3306. All three of the containers, the front end, back end, and MySQL containers, will all be able to communicate with each other on that assignment submission app network, which is really just it's a domain names type of service that Docker has, where assignment submission app actually resolves to probably 127.0.1. Or something like that. It's like its own local host within the containers. So that could be the way that we solve this problem. So for now, I'll leave it saying localhost for the application properties, and we will just have to deal with the fact that it's not able to connect to the database, which means it's not going to start, right? The entry point command, which is here. The entry point command tries to boot up the container and run Java, right? The Java, we start the Java process, and it, as we saw, it tries to start up Java or the app, I should say, and it's not able to because it fails to connect to the database, and therefore it stops running the server, the Tomcat server that's built into Spring Boot. So it's trying to start up the web server and it doesn't boot up. Therefore, I guess the container just exits because it can't start up. So yeah, that is the situation that we find ourselves in. So it's a little bit anticlimactic because I would have liked to have seen it up and running, and then we could go to localhost 8080 and see the app. Well, sort of see the back end of the app in in all of its glory. But so we'll need to fix this problem first, which means we need to connect it to a database. So in the next video, we will spin up that container, and hopefully in that next video we'll also be able to tie together this container, the back-end container, with that MySQL container as well. So I look forward to seeing you guys in that next lesson. If you haven't already done so, please do subscribe above if you like this content and want to see more. Give it a like as well so that others will benefit, because right now not a lot of people are seeing these videos, and if I want to spread the love. So please do spread the love, show other programmers out there how great the series is. If you find it to be great, please do give it a like. Cool. As always, take care of yourself. I look forward to seeing you in the next one. Bye for now.